This is the first introductory video about NFX Framework, and I want to explain what Unistack is. Well, first of all, I want to say that the target audience should be practicing software engineers, people who write code. People understand what they do, not puristically trained, academically trained purists who only care about their conceptual, righteousness. Let's not talk about code smells. Let's not talk about chicken and pigs, ITIL, body of knowledge, Gang of Four, test-driven nirvana, karmic mind maps. Not interested. What I'm interested in is trying to convey the practical applicability of what we did. And who are we? When I say we, I mean a group of 3 people. And most of us have over 20 years of practical experience creating business applications. Business software. When I say business software, I don't necessarily mean business like computing numbers for some clerks or something like that. But I mean real world systems. Okay, websites, back-end programming, and front-end programming as well. So let's talk about NFX. It implements a concept of unified stack of software. And it is a form of brain intellectual property compression of what we call it. So just like your compressor, your zip compressor, for example, it takes repetitive patterns and unifies them in a dictionary. Similar concept goes here. Okay, NFX stands for .NET Framework Extension. I started writing it back in 2003 or something like that. But it incorporates a lot of stuff that was created in the past, in Delphi and some, in C and C++, even from DOS days. What we use in NFX, we use CLR, very, very basic base class library. Not much fat class as what I call in .NET, like big frameworks like ASP.NET, for example. We only use stuff like strings, lists, arrays, dictionaries, compers of types, like string comper, for example. That's pretty much it. And I would tell you that from my practical experience, common language runtime is virtually bug-free at this point, practically bug-free. I know there are some problems with handling unmanaged code and stuff, but most of the time the CLR, common language runtime, is performing very well, and it doesn't crash and it doesn't burn. However, I cannot say the same things about bigger pieces of Microsoft frameworks like Link to SQL or Microsoft Component Designers and stuff like that never worked correctly. There was always a trouble with it. Okay, so NFX is built in .NET. It uses C# as a language, but it doesn't use the all of the heavy libraries here. So if we look at the references here, you're not going to find many references here. Okay, you're not going to find Silverlight, and you're not going to find a lot of other big Windows Presentation Foundation and all of that stuff, which is Microsoft specific, bloated, WinForms. Even we still support WinForms, but this is just an atavism, a feature coming from the past, and we're kind of dragging it along, but we're not planning to do any support for WinForms. It's a dying technology. NFX is centric for writing server applications. And another thing I want to tell you, I don't know about you, but I'd rather not use like crash dumps and debugger for low-level heavyweight artillery like this. I don't have time for it. I don't have intention for it. I started my development career on a Intel 8080 processor with 16 kilobytes of RAM, and I did my share of low-level programming, and I know very well how a computer operates, internally, what a direct memory access controller is, etc. But at the same time, that is not a good and proper way of development this day and age. If you deal with something like CLR, for example, if you have to go to Windows debugger and inspect your memory dumps or something, there is something wrong with it. So now I also want to talk a little bit about modern business software. So everything is web-centric. Now, is it good or bad? Well, you talk to people and they say everything is written, in our case, everything is written in PHP now. Is PHP a really good language for writing command line tools and computational jobs on Hadoop and stuff like that? Probably not. It's probably for web page rendering. No one these days does any background jobs, console tools, things like large data set processing, rendering, compression, God knows what else. Well, people of course do those things, but because their primary tool, let's say, is PHP or Node.js, now they have to do some crazy stuff. Now they need to use C++. Now, because the C++ is hard to do this kind of work, now let's use some of the Python. And this is how everything becomes more and more complex. Tons of third-party libraries. Understandable why people use a lot of third-party libraries, but that makes everything very complicated, as we will see in a second. So NFX, if we look at this folder here that contains all third-party libraries, for now, and I'm going to remove it from here, I have Apache Bench here so I can deploy it easily to whoever wants to develop. Apache Bench is just a web load testing tool that comes with Apache web server. Then I use NUnit as my framework for running my tests, and that's it. There are no third parties here, other than there are providers for MongoDB, MySQL. We use primary drivers, official drivers, for those projects. But other than that, there is nothing here. There is no ASP.NET. There is no MVC, Owen, Nancy, Razor, Newtonsoft, JSON, IIS, Windows Communication Foundation, Unity or Enterprise Library, nlog, Log4net, Ninject, and Hibernate, Link to SQL, Service Deck, Silverlight, Google Protocol buffers, Avro, Hadoop, AngularJS, Backbone, Dojo. I'm sure I missed probably another 10 cool, catchy, library names, and I don't use any of that. We don't use any of that here. So how do we get our job done? So that's the benefit of Unistack, is to reduce the number of formats, standards that need to be supported for some edge cases, really. Because someone writes a website, everything is cool, but then he needs to do some function, and for that, they bring the whole new library that depends on nlog. But that now you need to configure it for both nlog and log4net, because log4net is used, somewhere else in the code. And what I have done here, I've opened up a nice, nlog page on GitHub, and I don't want to criticize nlog in any way, shape, or form. It's a great logger, but I just want to talk about configuration, see how they use variables in their library. They understand variables in their or patterns in their configuration files. You see this? So you need to understand how this works. If you want to use nlog as your primary logging framework, you need to understand how this works. And they did a great job. Really like what they did here. Okay? Now, At the same time, here I open up a log4net manual. They also have libraries, but or variables rather. I'm sorry. They have variables, pattern matching or something, but the syntax is absolutely different. Now this is XML. This is XML probably from what I can see on the screen, but semantically they're completely different files or contents, documents. Okay, so here how you use variables. Automatic reconfiguration. Wow. This is all very clever. But let me ask you a simple question. Can I use this configuration mechanism to configure my, let's say, charge processor that processes my client's purchases? No, I cannot. Or if I could, then I need to understand how it works inside nlog and reuse some of the parsers and whatever logic from there in my business code. But can I do it? I probably could. Is this the right thing to do? Well, maybe it is. But then if some other component uses log4net, then I'm all stuck, because now I need to support this kind of configuration. I'm talking about semantical meaning of things that you have to put here. Okay, there is a lot of stuff here. Log4net is a very highly, reputable, product or component, whatever, has been used on the market for many years now. Oh my God, but it is a completely different concept. They have filters, they have appenders, these guys have something else. Very similar concept, but it's called differently. You configure, you have targets here, you configure them differently. And again, I'm not criticizing nlog or log4net in any way, shape, or form. What I want to say is that the moment you use both, and you may not have a control, because how do you know whether you have log4net in your application or you do not? Well, you know it as an architect, you probably do. We use log4net, right? Or as a developer, as an architect. But what if you don't want to use log4net anymore? What if you want to use something else? Okay, dependency injection. Okay, but then you need to know that someone needs to inject the logger. But then you need to create an abstraction for the logger if you want to support both log4net and this guy and Microsoft Enterprise Library. Then you need to create an abstraction that would work with three. Oh my God! But you configure this way, that way. It's a whole bunch of mess. There's got to be an easier way, to achieve the same effect. What I want to show you here is here I have some code. This is actually a class that represents an address in a group that control the network gate. That's a software firewall, a part of our framework, but that's besides the point. This is how I configure my fields or properties. I can use the setters on the properties. Those properties, they only have gets, they don't have sets. Okay, so this is how the configuration attribute gets applied for polymorphically, and everything just works. So I also use it here. Okay, now let's look at this guy here. This is telemetry instrumentation provider, the guy who sends the instrumentation information to a different machine. The telemetry, you view it remotely, okay? So I have some configuration properties here that are also configured. So those configuration elements will be called this: receiver node, site name, use log, and it will automatically bind them from config file. Now what I'm trying to show you is the benefit of Unistack. I have completely two different portions of the library. You can even look at the namespace here, completely different here and here, and they are configured the same way. And the syntax of the configuration is here. Okay, this is just one of the syntaxes, what we call a laconic configuration format. Here I set up my logger. I say say that I have a destination. Now, I may use the type in more than one place, so I put it in the variable name here, right here. It's just an attribute. And I use this here, right here. It's just the name of the type, CSV file destination. And then I can reuse it in multiple places if I need to. So I have variables, and I have the same syntax for all of the things in my config file. Here I have my web server, for example. I have a dispatcher. Now, this is Z1, test configuration that comes from some test, project manual test. That's why, I don't have it. I have a lot of comments here and stuff like that. But you see how easier it becomes because you can configure your web server handlers the same way how you configure your filters, the same way how you configure your pattern matches and stuff like that. And then for the data store, this uses PostgreSQL model data store that does all of the stuff for us. And there's some plain test password here, which is fine. You see this, it's a similar syntax for, so object store, the guy who keeps the objects in my in my persistency layer, so I can survive the application restart. The provider keeps them on the disk. I can substitute for a different provider. If you're familiar with the big memory concept, this is what it is. Every application has a big memory interface built in, and the provider says where you want to keep it on disk or in some big network heap or something like that. Instrumentation, that's what I showed you. Log instrumentation provider writes instrumentation messages to the log. So that's all you need. The provider, that's the name of it, and that's the type that satisfies the contract. So here I have some crazy stuff for network programming with the client transports, dump wires and formats, and I can use variables here, and I can use a lot of stuff. Now, here is another file for Erlang node, for an OTP node that is configured in the same fashion. Now, obviously, the syntax highlighting is off in this tool. This is Notepad++. I haven't changed the highlighting scheme for like 6 months or a year. But other than that, everything is configured in the same way. Now, having said this, the configuration framework that we have, it understands XML, of course, but we don't use XML anywhere because it's such a pain in the ass, pardon my French, to work with XML once you start working with laconic format, which is much more succinct and terse and easier to work with. Now, this is an XML, representation of some other, it's similar concept. Look, it's just more verbose. You see, you have more characters. Okay. So that, I think, whoever wanted to hear what I was trying to say already heard my message. My message is this. If you look at this crazy stuff here, those formula macro evaluation, for example, this is a variable, this is a macro, all of that stuff is not only for the logger, it's for everything. Because it's a unified stack of software, everything is written the same way. God knows why Microsoft has not done variable evaluation in their web configs. I have no idea. Now, another question, how do you build a centralized configuration where you can configure hundreds, if not thousands, of nodes from the same place? In Microsoft paradigm, it's a pain in the neck. Because they don't have an easy way to read your configuration from the database, for example. Well, you could do that with code, of course, but you need to do it every time. It's not built into the framework. It is built into our framework. It's not built into their framework. So I guess the point that I'm trying to make here is this. Unistack is a way of compression of your intricacies and nuances of your, as you know, the devil is always in the details. So we want to get rid of those nuances and little tiny details, and this works this way, that. So we want to unify how everything works. Okay, so that is what a Unistack approach is. So a few questions, that you can ask, or you can answer. I can ask, or I can answer, whatever. Are different process kinds like web server, console tool, a service daemon of a kind currently configured in the same way? So in your system, if you have a tool, a console tool, if you have a something like this, for example, something like this, how does this execute? Do you parse the command line? Do you parse all of those parameters in every tool? Now, because we don't, for example, we have a one of the kinds of configuration we have, it is a full command line parser that parses command line into configuration object. So to us, configuration is just a tree of nodes in memory, whether it comes from the database server, from the file, XML, laconic format, any format that we want to invent, or INI file. It all comes to the same thing. So, be it the NFX template compiler, that's the tool to compile the templates, okay? Be it the glue compiler, for example, to glue compiler, be it the tool to compile the the contract calling methods for the remote calls, what we call the technology we call glue. We have the same way how we even provide the help in the tool, okay? And or be it the RSC relational schema compiler. Be it the I went to the wrong folder here, I beg your pardon. RSC, be it the relational schema compiler. This is the very complex tool, and it takes a lot of things as an input, but variable evaluation, macro evaluation, it's all the same. My web server is configured the same way. Why do I have to think about web configs when web config works differently than some other app settings? And if I deal with WinForms, then my WinForms config is somewhere else. If I'm on Windows Vista, I recall it saves it somewhere, God knows where it does. And if you are on Windows 7, it puts it in the different folder. And if you're on Linux, then and you run on Mono, then it all screwed up because the config file is looked up in some other folder. Now, I don't have time for all of that stuff. Neither do my partners who help me participate in writing all of this framework. So we just need to get the job done. We don't have time for that, and that's what NFX is all about. It's not for purism, it's for practicality, okay? And not much code, no code. The less code we can produce, the better, okay? So another question I have is, I already asked the question, how do you guys store config development changes in the version controlled environment? How do you deploy your configuration files? Can you store them in one centralized? There is no concept in .NET Framework for centralized configuration as in cluster. Okay, so I have 25 different IIS instances. How do I configure all of them? How do I remember my changes? I probably could use TFS, but can I feed my web servers right from the TFS instance? Or do I need to copy the file somewhere? Who's going to do all of that? This is very complex. It can be all simplified many times. Do you ever have to wait for third-party vendors to fix bugs? Well, in the past 3 years, I haven't waited for anyone because I don't have any third parties. And that's a part of Unistack approach. You don't need those third parties once you have this. Now you may say, but this is crazy. What you are telling me is that basically you have written everything. Yeah, But that's not that much. Right now, I'll show it to you. You don't need all of that bloat that many people have, and they think, oh, we're so proud, we have so many components, so much value. It's not value. It's chaff. Like shredded paper. And I want to show to you next, real quick, is the this is the source code for NFX and the output that it creates. What you need. This is the whole web server, everything, 2.27 megabytes. Now everything else that you see here, this is the PostgreSQL SQL driver. This is MongoDB somewhere here, MongoDB driver base, and those are things supplied to us. Those are the only third parties we need to work. Everything else is those are tools that we use, our tools, internal tools. They're all written in NFX, like NTC, NFX template compiler, relational schema compiler. Telemetry viewer is a tool to view your instrumentation graphically. It is a Windows application, but other than that, you don't need all of this in runtime. You only need these 2 files. So actually, most of the applications just need this 1 file. That's it. Okay, so what does NFX have in it? Now let's quickly go through it, because we're running out of time on this video, recording. Like I said, there are no third-party references. This is the core assembly. If you look at the references, they're only base CLR objects. They work on mono, okay? And actually, what I did before, I actually took the exe file that I created on Windows, copied it to Linux machine, and ran it with mono. You don't even need to compile it on Linux. It works. Okay, so the application model brings the kind of a dependency injection root container for your application, be it a console app, web app, anything you want. It has a number of providers here that any application has. A log, an instrumentation sync, where you write your instrumentation messages. We're going to talk about it some other time. Throttling to control the flow rates, like decelerate, accelerate stuff. Config root. Everything gets configuration from right here. We don't use Microsoft configuration anywhere. It's not used. Okay. Data store. Any application has a concept of data source, data store. Now, if your application doesn't need it, or whatever component your application doesn't need, it is injected with a NOP, no operation counterpart, that does nothing. Okay. Object store, I explained what it is. It allows you to do like a large heaps of objects that survive the restart of your process. Glue allows you to glue contracts together between different machines. This completely supersedes Windows Communication Foundation for us. We don't use WCF. Yeah, that's right. Yes. Security Manager. We have this guy does like authentication, authorization, authorize the permission model. We have declarative or imperative permissions. We're going to talk about in some other video. There is a lot of stuff there, but there is no code, which tells me that the design is very good. Okay, a lot of functions, but no code. What it tells you, good design. Time source. Instead of doing like datetime now, we do application.timesource.now or UTC now. That allows us to inject time sources, synchronize clocks, and do other time zones and stuff like that. We don't rely on current computer time zone. We use this instead. Much easier, much simpler way of working with dates and timestamps. Event timer, schedule things in the future or whatever, something like a scheduler. Okay, you can schedule some callback to run 25 times every 5 seconds, from January 1st to January 31st. Okay, whatever. whatever you do in the application, it is always executed in the scope of the session. Not only web, but console app, it has a session. Whatever, the web has a session. Your daemon, your service has a session. A session has a user has a permission, and everything is based on that. Okay, so no Microsoft bloated stuff that deals with Active Directory and all that. We don't use any of that. We just bypass it, all of it. That's why it works very well on Linux. So this brings the question, is this a truly Microsoft solution? No, it is not. It uses common language runtime, it uses C#, and it uses very vast of what we have in .NET paradigm. C# is a very I think mature, good language. CLR is very stable, but other than that, all of those bloated libraries, we just don't use them. So the rest of this stuff here implements the application services. Now, code analysis unifies the way how we parse things. Okay, it brings the formal concept of language that is a factory class. Okay, that a factory, an object factory that produces lexers, parsers, and compilers. So that allows you to be polymorphic when you deal with different languages. So the languages that we have implemented is JSON, of course. It is natively supported in our framework. That's why we don't use JSON for .NET or whatever it's called, Newtonsoft and all of that stuff. We have all of that implemented right here. The similar way, we have C#, Lexer for C#. This is important. Why? Because we can do a lot of code analysis in C# using Lambda streams of Lambda functions, which is facilitated here by the pattern search, which is language agnostic. Okay, it's a predicate library that allows us to search in the token streams. Why? Because the token, we have done it as an abstract class, and every, then there is a C# token, a JSON token, XML token, etc. Okay, so what this allows us to do, it allows us to do pattern matches, just like you do with regular expressions, but much more interesting pattern matches, because we deal with tokens, not with characters. Okay, so string escapes, all of that stuff, crazy stuff, it's all done here. So here we have laconic language that we have for our configuration, very well tested. This is all covered with unit tests. And by the way, speaking of unit tests, we're not crazy about test-driven development at all. I think this is all about definition. And, some people say test-driven development and this, others say it's something else. We write functional tests that cover the functionality, because I want to test what I've just written. But I'm not going to write my code just for tests. This is absurd. The less code I write, the better. Okay, I don't want to just write code just because I do test-driven development. That's just the wrong pattern for NFX. That's the way it is. So source, I can supply source as a file, as a stream, as a memory buffer, as a vector. So using this code analysis concept here, someone could create a compiler for C# way faster than creating it from scratch, for example, or C++ or anything else, because like compiler errors, they're all encapsulated here in language processor, notification, message. You see all of that stuff is all well factored in the polymorphic fashion here. Okay. Collections. Some collections that we need, like 2D matrices and bit lists for QR codes, that we also generate as a part of NFX. Data access. We don't use any ORM. We don't use link to SQL and never will. We don't use Hibernate and Hibernate or anything like that. Everything that we use is right here for CRUD. Row set, typed schema, typed row, dynamic row, amorphic data, version changes between in the database. This is all accounted for. Different backends, different queries that get resolved by query resolver. You can create CRUD query that works with Oracle, then you need to re-implement it in MySQL or even in some Cassandra, for example, or not necessarily a SQL backend. You can do that. Okay, this is all factored in here. Queries are no longer XML or SQL based at all. They're completely agnostic and there is also a concept of query source. You can write some of the queries in your particular language and they get dynamically compiled in your code. This is very powerful, okay, and it's all right here. This is the whole source code, a few thousand lines. That's all you need. The cache server, cache store, similar to Microsoft memory cache, but speculative data structure, optionally prioritized objects get evicted. This way works way faster than Microsoft, sometimes 2.5 to 5 times faster for concurrent reads and writes. Completely lock-free implementation for read. Does not guarantee that your thread safe, but it doesn't have to be because it's a speculative cache store structure. Okay, uses memory barriers and stuff like that, not to do lock statement in a multi-threaded environment. Okay, it's right here, distributed. This is an awesome concept for distributed data stores. If you want to create a Facebook and you need to support 25 gigabytes, I don't even know how to call it, then you use this concept here because this gives you the proper architecture for a huge data stores with banks, with areas, with sharding, with balancing, with all of that. NFX does not provide the implementation for it, but we have another project called Bolt DB, Big Online Transaction Processing. It's a database that is written in OM cluster, a framework which is based on NFX that supports Facebook style or Facebook scale or Twitter scale, Google scale databases. Okay. So that's enough about data store environment. This is where all the configuration, macro evaluation, variable, cycles and variables are detected. If one variable points to another and that points back to the first one, all of that is handled. Macro runner reminds me of Perl in some regard. You can write scripts that are, look like Perl to me, right in your config files. Erlang, full support for Erlang language right here. One of the guys on our team is Serge Helenikov. He's one of the luminaries on Erlang project, and he has created this port of OTP.NET. Actually, he worked on the OTP.NET. This is not a port. This is a total from scratch rewrite of Erlang node on .NET. So this is an OTP node. This is all of the crazy stuff with TCP, and those are all Erlang types, vars, tuples, PIDs, process IDs, ports, atom tables, and all of that stuff. And this is all optimized with NFX. Some financial stuff, like value of time, amount. Well, this is notorious thing, currency and value. I don't understand why .NET and other, they don't have this type and don't have arithmetic with it. But anyway. A lot of things in our framework use this type. That's why I show it to you right now. Geometry, self-explanatory, some Cartesian utils. Doesn't have to be fancy, but covers most of the case, like lat long, haversine, distances. This is important for cluster programming to find the closest route, whether network-based or as a crow flies, what they call it. Glue. Well, this is replacement for Windows Communication Foundation for us. I'm not saying it's 100% what WCF does, that we do the same, and we will never do it, and we don't have to do it, and we have no intention of doing it. The reason is Windows Communication Foundation is written with tons of old and new and crazy arcane standards like we see web service extensions. If you recall, there was a Microsoft extra feature pack for web services, and then we don't need any of that stuff. So Glue idea is very simple. You have messages and you have endpoints, and you send messages between endpoints, okay? And how you create those messages, you use them using a trampoline that you create with the Glue compiler. Very similar to remote procedure call, only this is all contract based. You have a protocol, you have native bindings that are sync socket binding that uses TCP/IP with a binary serializer that serializes any kind of payload. The MPX stands for for multiplexing binding that uses asynchronous sockets, so you can send via the same socket back and forth at the same time asynchronous packets. Again, not packets, the messages, and it's all encapsulated from for you don't even know how it works, and you don't have to know. Okay, but very, very powerful framework here, and it allows you to inject inspectors that inspect messages and mutate messages, and it does synchronous and asynchronous unicast or multicast patterns. And I have a diagrams and explanation how it works on my blog omcode.com. Okay, health is like running unit tests at your project runtime, so you can run some health checks and see what assumptions are true or not when your program runs. Instrumentation, that's self-explanatory. It has telemetry, it has some histograms and analytical functions built in. It has gauges, it has events, it has an aggregation framework. It does map reduce in real time from multiple nodes in the cluster environments. You can accumulate much statistics, and it all gets displayed graphically for you, but I'll show it to you some other time. Inventorization, that's something we created. I'm not sure how far we're going to go with it. Allows you to attach metadata to inventorize your code, like what is the probability of this failure, so you can keep your documentation right in your code. Okay. As in NFX, we do not believe in automatically generated documentation, which is hard to read anyway. If you have an access to source code, that all of you will, whoever is interested, because this is all going to be open sourced, or already open sourced at this point, I believe. So you can look in the code. It's much better to read in the code. Look at the XML comments. I/O. The file system is completely abstracted. A local file system is just a subtype of the file system. So consequently, we have an implementation for SVN and Amazon S3. So how do you keep your pictures of your profile, user profile, on your website? Do not use local file system. Please use our new way of working with it via the interface, because this is a polymorphic, it's an abstract class. So once you get a reference to the file system, now you can support multiple handles, multiple file systems in the same process. And Apache HDFS, SVN, Git I don't have implemented. If you guys need it, you can implement it. It's very easy. How does one implement a file system? Local file system is only 3 classes. Okay, it has something called capabilities that, just look at it, supports versioning, supports transaction max file path length. I'm just showing you what kind of work we've done here, extracting the general features of file systems. Look at this stuff. It's pretty neat, don't you think so? This is local file system capabilities. It's a singleton, object returned from the local file system polymorphically per ifile system capabilities. Okay, it's just an interface. So you can determine what your current actual file system can or cannot do at runtime. Alright, so this is in the file system. In the NAT we have something called gate. Now this is a cool concept, because this is a software firewall that you can host right in your application. Now, why is it so cool? Because you can feed the firewall with some condition flags from your business code. So let's say someone starts to attack you from some IP address. You say, oh, you need to detect the denial of service attempt from this, on the hardware level. Well, you do, but there are some denial of service attacks that are much more clever. For example, session hijack or session flood is a good example. The session flood is one of the rules we have here, and you can create any kind of rules you want, and see, they're all configured the same way. Remember, I talked about Unistack. It's all the same thing. It's just the rule. You can create a rule and say that from this subnet, from this IP, or from this condition and this variable that you expose from your code, you want to decline traffic from 5 a.m. to 6 p.m. California standard, or whatever, standard time, mountain time, whatever you call it. So the traffic that comes into firewall is abstracted as some I traffic direction incoming, outgoing, from address to address. Addresses are just strings. So the firewall does not necessarily work as a network gate only on IP networks. You can run it on any kind of like USB port, serial port, God knows what else. HTTP incoming traffic, check this out. So HTTP listener request, so it is the kind of traffic that comes from the HTTP listener. General traffic. General traffic is just, for example, for use for some unit tests or something like that. Okay, so that I think explains a lot to those of you who know what I'm talking about. And the serializer, we have some streamers to efficiently write binary data with compression to streams. Logger. The logging framework with all kinds of destination service level agreements. Destination, what we call, is sync. I think the term sync is very overused term for many things, so we call it destination of the log. Same thing. SMTP, SQL Server, we support syslog, we support MongoDB and Postgre, and cascading with asynchronous or synchronous delivery with flood filters. That is to preclude things like if you get 25,000 messages a second, so you don't get 25,000 SMTP messages. You can put SMTP destination, wrap it in the flood filter, and then the flood filter will rectify 25,000 messages into one message per minute. That is going to say you got 25,000 messages, and now you get only one email with a report. Okay, the logger framework is all here. It's all flexible. It's all built in. Media, the tag codes, QR code we support, barcodes we want to support in future as well. The PDF rendering library, I laid some groundwork here, but haven't had a chance to implement it yet. But there is going to be a PDF renderer. The PDF renderer is going to be fed from the document model that you will be able to construct document object models in memory and render them into HTML, PDF, or God knows what else. Okay, so this is what media is for. This is the most incomplete namespace in NFX at this point. Okay. Operating system, well, some abstractions for working like getting performance counters, like CPU and RAM on Linux and on Windows. Parsing, those are some like text, but like parsing US telephone numbers, data entry utils, I think it's called, and stuff like that. This is cool. Natural text generator generates you random phrases from Jack London. I think this is Heart of Three or something. One of the famous Hearts of Three. Right, that's right. One of the stories. Used for testing, of course. So this is in parsing record model view model, what they call it. Really going to deprecate it because this was very useful for Windows form programming, not that much useful in web environments. Relational model, you create a script in config file and it creates the schemas for SQL, Oracle, Postgre, whatever, for any kind of backend. You can create domains and all of that stuff. Even if the backend doesn't support domain, you can still use it in the script and will recompile the SQL statement for you. Very flexible tool to support to target multiple databases like MySQL and Postgre and SQL Server, for example. So, for example, create sequence in Oracle, and I think it's called identity fields in Microsoft SQL Server. This tool will generate the script for you. Security, we have the whole security framework with permissions, authentication tokens, and God knows what else. CAPTCHA support is right here. Puzzle keypad is very good class that you can use on the web, or you don't have to use it on the web. You can use it on in the server applications anywhere. So CAPTCHA component. JSON, serialization, JSON, full support for that. Reading, writing CLR types and some CLR types and dynamics, okay, into dynamic, and writing back to reading and writing those types rows for the database programming. This is very, very handy, and you don't need any ORM framework, believe me. Once you have it, you'll just forget what ORM is. Okay, portable object document is the similar concept to like XML, only it's binary. You can export objects of any complexity, even with the cyclical references and stuff like that, and then you can read them back with different schema, and you can do document transforms, functional document transforms. Those are pretty much attributes with them functors, function pointers, that is, that you can specify to convert your data back and forth. The Slim format is very, very capable, very, very optimized serializer that does serialization of whole full object graphs, including cyclical object graphs. Doesn't require you to use any data contracts and all of that attributes, because most of the time, if you're in Unistack domain, you have to talk to some other server who runs the similar application, only it's a different server. So why do you need to serialize as XML and JSON? This is stupid. So this is what Slim Serializer is, a high efficiency binary serializer. It is similar somewhat to Google, what is it called? Google, protocol buffers. Only Google protocol buffers requires you to explicitly specify the size of the sequence of fields, and it does not support cyclical references. This does. This is a CLR serializer. It is not interoperable with web services, and it is not REST friendly. So here a lot of users will say, oh, how can you not? Well, that's what it is. That's why it's so efficient, works very well. This is used in many places in the system in conjunction with Glue to create so-called supercomputers. A supercomputer is a computer that is comprised of tens, if not hundreds, of nodes, and they all execute the same application at the same time. If you're familiar, like with IBM supercomputers and stuff like that, this is for this. This is to have, together with the application model volatile that allows you to store objects in global heaps, you can build systems that share memory and share your computational resources and share your, so pretend that your 25 different computers are actually one machine. Okay, and we can talk about it. It's a complicated subject of cloud cluster programming that I'm going to do a different video on it. Service model, similar concept, abstraction of services. If you're familiar with Erlang process, lightweight process that you spawn, somewhat similar to Microsoft Task, only this was created, like 10 years before a task was ever devised. You can control service with stop, wait, start, stop, wait for a complete stop, and stuff like that. A lot of system components in NFX, they implement this, they derive from this class, service. Okay, the system services. Templatization, very similar concept to what you guys used to in, like web. When you write templates. Only templates here are not text-based. They're absolutely abstract. You can create an audio template based on an MP3 file, or a bitmap template based on a bitmap with placeholders for your people's faces. But most of the templates that you're going to use more often than anything else is the text C# template compiler derivatives that are going to be based on text files and use C# script. Okay, if you're familiar with Microsoft Razor, you know what I'm talking about, okay? So the whole templatization is not tied to web in any way, shape, or form. You can use the same templates to create emails, to create PDF files, to create God knows what else you want to create, okay? This is what templates are. Okay, throttling, you can throttle things up and down, control the throughputs. You can declaratively or imperatively specify how fast it, what is the throughput, time sliding window throttle, or time spacing throttles. Some interesting implementation here with integer mathematics. Was a lot of stuff was brought here, from distributed computing projects and network programming. Time, timers, time sources, etc. So when your process gets hydrated when it starts, your application container gets hydrated with all of those services. If those services are not applicable or not configured, you get a NOP provider, no operation provider. Let's look at NOP glue, for example. What does it do? Nothing. But you're never going to get a null reference exception. You don't need to check in the code 25,000 times. If this is null, you don't do that. Okay, so that's pretty much it for the NFX core. Everything else here, I'll just quickly, because we're really running out of time. The web, we have email server that understands email queues, iMailer, mailer server, blah, blah, blah. So that's for those are technologies actually related to the World Wide Web. So that's why I put it in the separate assembly here. Geo lookup, resolve IP addresses to, to real, location information. This is based on the open data set. You just dump a few binary files on your drive, and this installs automatically as a hook in your web server that I'm going to talk about in a few minutes. I/O, we have Amazon S3 file system. Remember I talked about file system? This is the implementation of the file system class for Amazon. Payment framework, to clear the payments, we have Stripe for now. PayPal and others are coming. Social, this is the whole interface for all social networks, 100% polymorphic. You can post information to social networks. You can link in or, log in, authorize with open auth 2 or whatever it's called. So Facebook and Twitter is here, and some other frameworks as well. And last but not least, this is the whole web server for us. We do not use IIS. We use a hybrid web server that has everything we need. All of the filters, all of the pipeline. If you're familiar with ASP.NET, this is way more flexible, pliable, and customizable than what Microsoft has done with ASP.NET. And MVC framework and templatization, I explained what templates are. Here is the Wave template. So this whole concept is called Wave, Web Application View Enhanced. And then here we have the whole JavaScript framework, which is a reactive framework. It's right here. Reactive Framework is actually right here, this one file. That allows you to do a reactive programming. You can bind things to on the server. It's only 3,000 lines of code, uncompressed. Very, very, very terse framework. We also have Web GUI, Wave GUI, that has tree view. It has dialog manager, and some other things. So we don't use any third-party libraries for web programming. Okay. Country flags right here. This is used by GeoFilter, I think, GeoLookup filter, that uses that service that I talked about. This is the whole implementation. It matches up your caller with a country and injects it transparently with a work filter, your web work filter, that injects it with a context. Other than that, our MVC framework is way more pliable than the one that Microsoft has, and this is the whole implementation. There is nothing here. Our actions return objects, not action results. You can return action result, which is just an interface with an execute, and here is everything we need. Client record, JSON result. This is the one that used for reactive programming that I talked about. It generates JSON record initialization JSON on the client, and it's all transparent. You don't ever need to look in here, and it does all of the dynamic binding with optional parameters, conversions, and the most interesting thing here, this is really stupid, why no one ever considered it. The root extension method, string value conversion, all of the objects you can get as nullable byte, as this, as that, and it converts all of the values for you. This is so makes your life so easy. Wherever you are, you just say any object as byte, as this, as that, and it can either do a strict conversion, like convert a Boolean value from string. If you say true, it will return you true. If you say 1, it will return you true. If you say strict true, then if you say 25, it will say conversion error. Okay. It also understands all of the basic types, primitive types, and their nullable counterparts, which is extremely important. It initializes the dictionary here and does the conversion for you. Okay, so that concludes for the NFX framework overview.